watched the last video, resistance combination solved, you've been able to determine that we have a total resistance here of 200 ohms. So just continuing on from that, we can find out what our total current in the circuit is. IT equals ET over RT. So we got 0.6 of an amp. We're going to call that 600 milliamps multiplied by 1,000. So now we're at 600 milliamps. And all the current has to go out of here, goes through here, and some of it goes through there, and the rest goes there. And then, of course, this comes through there and combines with that. This comes through here and combines with that. So I've got this one resistor where all of that current is going through there. So I1, the current through the resistor 1 must equal 600 milliamps. And now we can find our, just using our Ohm's law, we can find our voltages here. So E1 equals I1 times R1. 100 times 0.6 or 600 milliamps is 60 volts. So now we've got a 60 volt drop here to here, just drop 60 volts. So if I was the meter, I was reading from here to here, I was reading 120, and then I keep that one there, and then I read from here to here, I've got this 60 volt drop here. So I know that my new voltage from this point to this point, or this point here, is going to be 60 volts. Then we can find how much current we have going through there. I8 equals E8 divided by R8. So we've got 200 milliamps through here. Now we started with 600 over here. This is our total, and 600 is 200 is coming back this way. So we've got some value going through here. So this value here must have a certain amount of current going through it. So R2, if I had 600 here, 200 here, it combines, I must have 400 milliamps here. And then you can just find your voltage drop there. R2 is going to have a voltage drop of 30 volts. So I've got a voltage drop there of 30 volts. So my voltmeter from here to here was reading 60 volts. This is the same thing as here to here. And now my voltmeter is going to read a voltage drop from here to here, which is going to be the applied voltage minus this voltage drop here, minus this voltage drop here. So 60, 120 minus the 60, minus the 30. So I should have a value here that equals that, which should be 30 volts. And then just using Ohm's law, you can calculate that your I7 is going to be 200 milliamps. And then you get to this point. So I've got, in terms of current, I've got this current flows through this loop and then back. So the current is going to be the same for all of these because they're in series. And the amount of current flowing through there is going to be 200 milliamps. So we've got this 200 milliamps meeting up with some value here that equals the 400 milliamps. So this must be 200 milliamps. And like I said, these are all the same. And now you can just work on getting your individual voltage drops. So just Ohm's law, we've got voltage at 3, we got 4 volts. Voltage at 4, we've got 8 volts. Voltage at 5, we've got 6 volts. And the voltage at 6, we've got 12 volts. The voltage, the sum of these individual voltage drops in this linear network here, 12 plus 6 plus 8 plus 4, must equal the total voltage right here and what it's in parallel with. So 30 volts here, 12, 18 plus another 12 is 30 volts. So we got 30 volts on this side, 30 volts in parallel with that. So we know that we've done that correctly.